Okay, good morning, accounting students. This is the second in the working capital management videos. So it's third part of our financial management. We've spoken about receivables. We're going to talk a little bit about inventory management now. And again, when we're talking about working capital, we know we want to minimize the amount of money that's invested in working capital because it's not out there making money for you. It's sitting, it's doing nothing. However, we need to recognize that we have to have, for example, inventory. Imagine if you go to a shop, maybe you're a skier, snowboarder, and you go to a ski shop, apparel shop, or equipment shop, and you go there to buy a snowboard and they don't have the right snowboard. What's going to happen? You're going to walk out, you're not going to buy the product, and they've lost out on a sale. You go back again to maybe buy some snowboard boots, and again, they don't have the right size or equipment. You're going to walk out, you're not going to buy it. And probably at that stage, you probably never ever go back to them again. So they would have lost out on a sale from you. So if, and I'm looking at a chart over here, if I look at zero here and the level of inventory, if I have very low levels of inventory, you're going to have these opportunity costs where you're going to lose out on sale because you don't have the product on the shelf. And so there's a very, very, very high opportunity cost if you have low levels of inventory. And obviously, the more inventory you have available, the less chance you're going to be without inventory and unable to sell to a customer. Okay, so those are our opportunity costs. Now, mixed with that, we've got to realize that more inventory on hand we have, there's more money tied up in inventory. And so our costs for our holding costs are going to kind of be something like along those lines. The more inventory you have, the more cost you have. If you just think about the money that's tied up in the inventory, that could be in the bank earning you interest, but also you've got to have warehouse space, you've got to have heating, you've got to have cooling, you've got to have insurance, you've got to have inventory management systems, you've got to have staff involved. So there's a lot of costs involved in having inventory on hand. So we've got these two different sets of costs here that are kind of opposite to each other. One that wants us to have very little, the other that wants us to have a lot. Where do you find the right level of inventory? Well, you want to optimize those costs. So if you put the two sets of costs together, you'll end up with a chart that looks like that. Now, I'm not going to go and try to draw the mathematical function for you, but from your maths class, you'll know, well, if you go and differentiate that function, you can find the minimum point here, in other words, a minimum point, and at that minimum point, you can then go and work out what the optimal level of inventory will be. From that optimal level of inventory, they've worked out something called the economic order quantity. So this is the amount that you should order at one particular time, and this is a formula you'll come across a lot in accounting. And it's economic order quantity. It's the square root of 2 times the total uses for a year multiplied by the order cost divided by the average carrying cost per unit. So CC stands for average carrying cost per unit. And these examples that I'm going to go through and have gone through are in your notes. What I would like to do now is just go through a little chart of kind of what goes on in inventory, and then we'll work through the example. We'll just pick up a couple of points on that example that is in your notes. So the first thing we want to talk about with inventory is obviously if you start off with a certain level, what's going to happen on my x-axis, I got time here. This is quantity and time. As I sell the inventory or use the inventory, it's going to go down until the next batch that I've ordered arrives. Then it'll go back up again, and then it'll go down, and then back up, and then down. Now, I'm assuming that this rate is going to be constant. It might differ. It might go down more rapidly over weekends, and less during the week. And then for business type organizations, it'll go very down rapidly during the week, and it won't move at weekends. So again, we've got to use some simplifications there just to keep it easy for now. So the amount here, that amount over there, that would be your order quantity. It's the amount that you order at a time. And that hopefully we'd get through the economic order quantity over here. What's important is you'll see that I never went down to zero. Most organizations try to keep what we call a certain level of safety stock or safety inventory on hand. Why? Well, can you imagine that you normally order your inventory if you're in Farmington from, say, Portland or Boston? You place an order in Boston, and it normally takes 2 days to arrive. Guess what? Boston's out of inventory. And now they've got to get it from, say, Miami That could take 5 days to get to you. So if you placed an order at that particular point and you're expecting to get it in 2 days, but it's going to take 5 days now, you would run out of inventory. And then we'd have that problem of lost customers. So to work out that safety stock or safety inventory level, we typically want to know how much longer or what's the maximum time that our order could be delayed. And then how much would we use during that maximum time? And we will put that as we refer to as safety stock, or that minimum inventory that we need to have on hand. There's going to be a couple of other things I want to point out on this graph. Average inventory on hand, this is inventory we're funding, will be safety stock plus average of this over here. And the average will be exactly halfway through there. So it's safety stock plus half of the average order quantity. So half the average order quantity plus safety stock will give you average inventory. And finally, the last point will be that we need to talk about is the reorder point. When do you tell your computer system that I need to reorder inventory? There needs to be some sort of level that when inventory levels get down to that point, the computer system automatically makes that order. And that is known as the reorder point. How do we work it out? Well, we want to say, well, what is the normal delivery period? So if the normal delivery period is, say, 2 days, how much inventory will we use in 2 days? And then you take that 2-day period times the average inventory you use, and that gets added to your safety stock, and that will give you your reorder point. Okay. And again, it might sound a little bit complicated, but it's actually very, very simplified from what it is in the real world. This will be computer generated. It'll generate an order for a new purchase. Then the stores manager would approve that. In the olden days, and there are some businesses still work like this, they might have a big drum with the components inside it and would have a red line inside it. And when the inventory goes down to the red line, then that person would notify the store manager and you would go and place a new order. Okay, this is the example from the notes. I just want to pick up a couple of calculations out of here. So for example, if I wanted to work out the economic order quantity, this is our usage, 1.12 million items. We've typically been ordering in batches of 10,000, but we don't know if that's the right quantity. Each unit costs $10 and our carrying costs are 10%. So that's in a percentage. So if we want to know the carrying cost per unit, we take 10% times the $10 and that gives us $1. Conveniently chosen for this calculation because we want that as the denominator. Then order cost is $100 per order. That's for delivery costs and transaction costs. And then the normal delivery takes 5 days, and they've decided up front they want safety stock of 2,000. You could set that, or you could work out the maximum delay period. Okay, so if we wanted the economic order quantity in this particular case, it's the square root of 2 times the total usage times the order cost, which is 100, divided by 1, and that will give us the economic order quantity. This is going to give us some very, very big numbers over here. Okay, and then I want the square root of that. Okay, and that gives me, again, assuming I haven't made any errors, it gives me 15,000. So actually, they've only been ordering in batches of 10,000. I should be ordering in batches of 15,000. So, and it doesn't matter if it's not exactly 15. Again, do the working on your calculator. If we then, say, for example, wanted to know what is our reorder point, so how much do we use per day? So we got 1, 1, 2, 5, 1, 2, 3, and we divided by the number of days. Now here's one of those things that in finance, they tend to use 360. We know there's 365 or 366, in this case, a leap year days in the year. I think this is done for bankers' holidays or something like that. There's a history behind it. So our average uses is 1, 1, 2, 5, 3, divided by 360. So average usage is 3,125 a day. So what would our reorder point be? Well, it's going to be the safety stock, which is the 2,000 plus Delivery takes 5 days times the 3125. And that will give us the reorder point. The last thing I want to talk about is to do a calculation to look at total inventory costs. Obviously, we need to know our average inventory. So average inventory, if we got the reorder point is 15,000 and the safety stock's 2,000, our average inventory is going to be safety stock, which is 2,000, plus half of our order quantity. So that's 7,500 plus that, which is going to give us 9,500. Okay, so the last thing to do is to say, what would our total inventory cost be? And we can do this on the old method of ordering 10,000, or we can do it on the new method of the economic order quantity. I'm going to go with the new method. Our total inventory costs are going to consist of two amounts. The order costs, okay, which I'll try to minimize, and then the average holding costs. So I'm going to go for the average holding costs. So my average holding cost, so this is total cost. So average holding costs, I've got 9,500 units, okay, that I'm holding. And my average holding cost per year is $1. 10% times the $10 value. So that'll be my average holding costs. Now, what about my ordering costs? Because every order costs $100. Well, I have a total of 1,211,250,000. That's what I use in a year. I make orders and batches of 15,000. That'll tell me the number of orders that I make, and I multiply that by $100, the cost of each order, and that will tell me my total inventory costs. Now, what you could do is you could go and do this calculation using the economic order quantity, and then you can also go back and say, how would this have looked if I was ordering batches of 10,000? And you can compare the two, and you'll see that you definitely save costs. Okay, so that is inventory management, or as much as you need to know about inventory management under the financial management component. Thank you.